First of all, welcome everyone to this webinar on how to deploy AI agents in engineering with a specific focus on building competitive advantage. Um, Last year was really progressive in terms of agent. We saw adoption of AI agents across industries, the technology maturing through a lot of different evolutions. And we wanted to share some of our learnings, not just from Synera, but also have um, others who did this successfully address the ones that are curious. And that's why I'm very curious and excited to see what Ryan from NASA and Florian here are to present. But before they introduce, my name is Ram. I'm the head of AI at Synera. I work closely with all our customers, help us understand what problems that are potential to solve with agents and build the roadmap around them. Uh, and I'm super honored and grateful to have Ryan with us. Ryan, giving it to you for a short introduction.
Sure. So I'm Ryan McClellan, AI and Fusion lead here at NASA Goddard, and sort of a nuts and bolts engineer that likes to build structures, and I'll talk about that. But I've ended up in the AI world and really excited about what AI agents are going to be capable of.
Awesome. Thanks for being here with us, Ryan. And we also have Florian with us, who's team lead of digital engineering at ARRK. Florian has a lot of exciting practical implementation lessons to share with us. But Florian, more about you, please.
Yeah, thank you, Ram. I'm Florian. I also have a mechanical engineer background. After that, I headed into the direction of software development and also AI and multi-agent systems. And currently at ARRK, I'm responsible for the digital transformation and innovation in engineering, both for our clients, internal and external. Thank you.
Awesome. I'm already looking forward to things that you will share. Uh, but before we get started, I want to again give our audience here an overview of what's about to happen over the next 1 hour. We will start with talking about organizational challenges that we see in terms of what's happening in not just agent, but in terms of different business impact that agents can have. Um, and once we have the problem in mind, it would be amazing to see Ryan's practical application of building text to telescope, his vision of leading AI at NASA, how that fits along with Synera's story. And then once we have that as a practical example, we can then see and hear from Florian what do typically organizations start with, what are some lessons that we can learn from the work at ARRK. And then we will have a short summary wrapping up the key learnings from Ryan and Florian, and of course a short Q&A session, not just at the end, but also between the sessions. So if you already have any questions, as promised in my LinkedIn post, now is your time to just post it on the chat or the QA session, and we will go over them towards the end. But before we get into our content, we are interested to and curious to see where you're coming at. So I would encourage everyone to participate in this short poll and answer the question, how familiar are you with AI agent and their potential benefit for engineering workflows? So that would already give a sense of how much awareness has spread, but also how powerful agents are. So let's give it some time and see what results we come up with. Ryan, Florian, have you observed a trend when you talk to your colleagues and your peers, how this adoption has changed over time?
Yeah, I guess.
think on our end, oh, go ahead, Florian.
Go on, Ryan, please.
I think on our end, we've seen since we have an internal chatbot we can use with our work data, we've seen just the awareness of AI, and what it's capable of grow, and then that lead to agents. That's sort of like the gateway, I think, is the chatbots.
Yeah.
Yeah, similar here. So at the beginning, AI was just like everyone talked about AI, but no one really used it. And yeah, managers like to hear AI topics and to talk about it. But now all the engineers really use AI and see the benefits, and that's why yeah, it changed, and it's not only talking anymore, it's doing, I would say.
Absolutely. And I think also the results are converging on screen here. It looks like we have quite a educated and aware audience here. So very familiar with how AI agents can automate. I think for some first touch points for the majority of folks here. So I think what we have for today is going to be a great kickstart for not just the beginners, but also for people to see how others are doing it. And that already brings me to talk a little bit about why this is so important and why we wanted to host this webinar. Um, Over the last 2 years, we have been working on agent, and and the reason organization adopt this are because stemming from a lot of challenges happening. I think Florian and Ryan will also touch upon this, but three big macro problems that we see happening now are either the talent shortages, so a lot of specific domain engineers that are getting harder to find and have in our teams. Also, productivity pressure is getting high. Everybody, I guess, has to do a lot with less. So there seems to be a need to get rid of low value tasks and focus on high value tasks. And that leads to bottlenecks. So when people are being pulled upon into different projects with different expertise, it definitely creates a bottleneck in the whole product development process. And we see this evident in the bigger studies. Usually it's talked about needing speed, but also lacking people to match that speed. And so our goal at Synera was to look into this problem and see what's happening. I want to quote another study here that tried to see where do engineers spend most of their time. And there were two categories. That was, okay, small to medium organizations, but also large organization. And the categories were four. So that was meetings, where we spend most of our time, getting interrupted and having to context switch a lot, also a quite almost significant share of time, and repetitive manual tasks, either using software or having to do those tasks again and again. And then inefficient collaboration, which is obviously on the lower side, but these are some of the bigger pain points where we as engineers lose time. So the two things that we take away are productivity problems are not just software problems. So there is more beneath those software in our organizations that lead up to those things. And as the engineering complexity and work scales, the complex or the magnitude of those issues also scale. So they have a bigger impact. So the challenge is not just connecting or solving software problem, but how do we tackle this kind of a bigger organizational problem? Because that seems to be the key to accelerate things drastically. And what we try to do is use automation with agents for doing multi-step, multi-tool processes. So that already gets rid of two big chunks, not being interrupted at work, but also not having to do repetitive manual tasks. But the other two things that still remain a bigger problem, and that is where multi-agents can actually work a lot. And those are the places where context needs to be passed along. It's not just a simple data type that's being passed along, but context. And that is the reason why things like multi-agent system or agentic AI fits well, because it solves a bigger magnitude of things. But looking into why that arises, because this is how a swim lane at typical organizations look like. So there are a group of engineers who are involved. We all start with a complex process. We are bound to do documentation. We need to align. We need to find time. So the actual project work seems to be only a fraction of what we are spending times upon. And therefore, this is a good problem to apply multi-agent, because now the more we give away our repetitive tasks to agent, the overall time to develop parts drastically reduce. And the agents are also self-sufficient because they are powered by large language model that they can document and share context along the go. That's where we see the challenge that motivates us to, or organizations to, go into agent. But before we see them in action, I want to quickly touch upon, for people who are new here, as we saw in the poll, what are those agents? So Synera's agent are basically LLM powered, large language model powered, and these agents combine two things. They take in a user request, and their job is to give a response. And this happens through large language model. Now, the challenge is to make it engineering ready. So what we do is we take the large language model, give it instructions on the specific role, equip it with context in the form of memory, but also company knowledge that has been gathered over many years. And then, most important, give it a Synera workflow as a tool. And now this agent can take in an engineering request, use its tools, and give out a response that's grounded in engineering reality. And now if we scaffold this idea, we end up with multi-agent system because reality is much more complex. So we try to imagine the whole organization as a multi-agentic system. Let's say we pass in the requirements to that system. At the top, we will have a management layer. These are agents who are predominantly focused on communication and decision making. These agents then talk to engineering agents. Here is where we encode a lot of engineering knowledge, and they use engineering tools. And this system works together as a whole. And now when we give a requirement to it, they all work together, use their tools, reason, and come up with a solution. And that's basically what Synera's multi-agent system does. Now, how do we get there? It's a 4-step process. We start with a low-code environment where we try to map out things that can be put into rules. So that's where we do a lot of modeling. We connect it to any major engineering tool. So we are partners. We have a strong marketplace that connects to a lot of engineering tools. The third step is to publish this workflow to external humans or agents. So that's our Synera run on a server that we try to publish these tools. And at the end, we equip those tools to those agents. And that is typically how Synera helps you in digitalizing your work, making them reusable, and also equipping them with agents. Now, that was already a lot of theory from me, and that's why I'm super excited to hand it over to Ryan, who will give us an overview on how his vision of text to spaceship, but also how he has worked on text to telescope. Ryan, it's my pleasure to hand it over to you. I'm really looking forward.
All right, excited to talk about what we've been doing here. All right, I think my screen is being shared here. So this is NASA's text to spaceship vision. So I'm going to talk about how we're using AI at NASA to accelerate our exploration of the universe. And I'm going to start with these evolved structures, these really organic looking, amazing performing structures, and how that led us to multi-agent systems, where we're not just talking about making individual structures or components, we're talking about designing the whole spaceship using AI. And it really comes down to the science fiction dream that a lot of us had as kids, is this future in space where there are a lot of people living in space, there are spaceships zooming all around. But then comes the reality. So something like the International Space Station, which is amazing. It's the second brightest thing in the night sky after the moon. But it took 25 years and $100 billion to develop, and Sleep 7. So that doesn't really scale to that, amazing future that I had in mind as a kid. And working at NASA, I've worked on Hubble Space Telescope, International Space Station, astronaut power tools, and the Nancy Grace Roman Space Telescope. And you learn that space is hard, and there's reasons that it slows, because it takes a lot of thinking, it takes a lot of work. But now, in the era of digital intelligence, of AI, I think that bright future is back on the table. So we started with something simple, which is a balloon mission. It's a mission where we can sort of take more risks. This mission goes up above Antarctica and looks at exoplanet atmospheres, which is pretty amazing that you can do that from a balloon. But it had a simple problem. We needed to attach this tip-tilt assembly to the back of this telescope. Seems simple, but the requirements were really tight. So the traditional way with, an engineer doing CAD and an engineering doing FEM and handing models back and forth, we couldn't meet the performance and manufacturing requirements for this bracket. But using our evolved structures technique, one engineer powered by AI in an hour can do over 100 iterations and come up with a design that's lighter, stiffer, stronger, and more manufacturable. And this technique was so powerful that we started scaling it across our missions. So these are a bunch of different parts for the Mars sample return mission. And in some cases, they enabled us to do things that we couldn't have done otherwise, reach performance goals that were not possible with just traditional designs. And again, because we had a lot of work to do, we got very busy making these evolved structures, we standardized our inputs to the process. So we made this form that you fill out of this structure, here are all the requirements, and define the requirements tightly. And then we wrote up a process for how we take those requirements and then we turn them into inputs into software. In this case, we were using Fusion 360. And then when we found out about Synera, we thought, well, hey, we have standard inputs, we have a process. Let's turn that into a workflow, basically turn it into code. So we had actually a couple brilliant interns who were able to get this working in about a week. And the power of this is when you've turned your process into code, you can just put it into other loops and you can use it on a vast variety of applications. So something that's sort of analogous to this tip tilt bracket you can do with this workflow, or you can do something like this. Same workflow, very different structure. And it's interesting for this particular piece, the inputs came from an AI agent. They actually didn't come from a human operator. So buoyed by that, we got into developing multi-agent systems. So I'm going to talk about our text-to-telescope system and then show a brief demo of it in action. So you have a telescope supervisor agent that sort of has to know what its responsibility is, who's working for it, what tools they have, and it breaks the requirements down that you might enter in natural language so that the digital employees beneath it can do their jobs. And then you have an optical design agent, and the tool that it has access to is a Python-based reinforcement learning tool that we custom built. And then it has access to an optomechanical design agent that encodes our standards for how we mount optics and does computational design and CAD. And then an FEA agent does the analysis. If you have active mirror elements, you may need a harnessing agent, and then a reporting agent to make sense of it to the human. And now to look at that really fast in action, you have the supervisor agent that you're connecting up to a large language model. And then you're giving it the information about, what employees it has, what they're going to do, what the inputs and outputs to expect are. And then you're wiring it up to the other agents. So it's giving it a communication path. And then you're enabling the agents to communicate with each other. And also telling each of those agents, what their responsibility is, what tools they have so they can do their job. Now you're going to see interacting with the system. In this case, we're using like an evaluation set from this bright mirror constellation and giving it, the inputs that you want that telescope to perform. And now it's taking those inputs and it's turning them to the standardized inputs that the agents are going to expect. Now it's going ahead and running the agentic workflow. And you can see very quickly it's come up with a design. And now what we're doing is looking at the communication between the agents, how they're talking to each other to make sure they sort of done something that makes sense. And here you can see what the CAD agent has done. It talks about what its inputs and outputs are. The FEA agent, you can see what the stress margins are. And then with the reporting agent, it makes it intelligible and easy to digest for the human operator. So you can see all the stresses, modes, and how the system performs. So something like this can really accelerate being able to build not just individual parts, but systems of parts. And we need that not just for the optical components, but for all aspects of our missions. So for the communication system, for the propulsion system, for the solar array system, we have a lot of work to do to build out all of these different computational design and agentic systems. And If you think about what agents do in the system, they convert our natural language goals into a standardized set of inputs, so the tools and other agents know how to deal with them. They help apply knowledge, so your company's knowledge, knowledge databases, or knowledge uh, that is put into the prompt. They apply common sense and intuition, so they might know what dial to turn to make something lighter. They orchestrate the automation of tools, they communicate with each other, and they help us interact with the outputs in a human understandable way and act as design collaborators. And the ultimate vision that everyone has is the Tony Stark Jarvis, but a multiplayer Jarvis, really. So here's how I see, for those that are more advanced with agents, what I see the agentic engineering future being. And that is an ecosystem of cloud deployed AI agent accessible design tools. And they're all linked together by some agentic orchestration layer. And the agent can access both your internal tools and potentially external tools via APIs, model context protocol, or agent to agent protocols, just all ways that they can talk via software. And this will enable rapid democratized hardware development. So to give a more concrete example, imagine a satellite lead agent, and it accesses this telescope design agent that I previously mentioned, an orbital dynamics agent that we've written in-house, or it might access a battery agent from a company that makes batteries, and you pass your requirements to that battery agent, and it creates a design, builds the RFQ, and then feeds that back to you. Or something like reaction wheels. Again, you supply the requirements to an external agent, and then it feeds back to you a design, and you can iterate on that. A very powerful instead to sort of replacing some of the slower human interactions that happen between organizations. So to conclude, AI is radically changing the way hardware is developed. And there's a tremendous opportunity to both accelerate the speed of development and unlock game-changing performance improvements as AI finds solutions that humans might not have. And in the case of NASA, accelerate our exploration and understanding of the universe. Thanks.
Thank you so much, Ryan. I think that was a very fabulous examples of multi-agents action I have seen. I think I can also share it for everyone who saw this in action. I have a couple of questions. I want to also mirror some of the questions that already the audience asked. I think Kent asked a really good question. How do you ensure that you can pick the right information at the right time? And any thoughts on how you approach, especially this case where a lot of the knowledge is either in the head or not even documented? So how did you approach this journey to come until this place?
So first I'll address the knowledge capture. So you have to be intentional about that. And there's a couple different ways to do it. Sometimes the knowledge gets encoded in the workflow itself. So for instance, in our workflow for text to structure, there are requirements that we have around, how much sort of material you need around the head of a bolt. And those are directly encoded. And then if you have knowledge that is maybe a little softer, that you have to put in the prompt. But then how do you get that? One technique that we use here is to, hold interviews with our experts and record them. And then you can use AI to distill those recordings and sort of like, pull out the nuggets of knowledge that you can then put into the agent. And I think the other question was, how do you make sure they have the right information at the right time? And I guess one thing is to start with anthropomorphizing agents. Think of them as employees. So what would an employee need to know to do their job? And you give the AI agent similar information. You don't want to give it too much information, say about a subsystem that it doesn't have anything to do with. That's going to confuse it. But you do want to make sure it, just like an employee has a top level understanding of, oh, we're trying to achieve this as an organization, you also have to have that. And then you have to have evaluations so that you iterate on this process and you make sure that they have the right information and you're getting good results.
That makes sense. I think treating agents as humans and trying to extract knowledge and putting them into action definitely seems also a very practical step to start. not having to wait for something else to come. There is a second question I wanted to ask Ryan is, you mentioned in in your vision for the future multiple domains, and how do you treat LLMs or these agents to bridge those domains? Do you see them as kind of an interface, or LLMs an interface, or agents an interface between what typically takes a lot of time to interface?
Yeah, it's one of the things. So, thinking of agents as people isn't always correct. And one of the things that's different about agents is that, these LLMs that you're tapping into, they can tell you how to tile your bathroom, they can help you plan a vacation, or they can, access your workflow. They have a vast amount of knowledge. So they do work as excellent interpreters. They, even with language, right? They can serve as interpreters.
Yeah.
So when you're trying to take, each domain has its own lingo. When you're trying to like convert between domains, they're actually excellent at that.
Yeah, I think that validates a lot of real value agents bring. It's definitely bridging those two knowledge silos into one glue mechanism. I think there are a lot of questions I can keep asking, and the audience will keep asking. But thanks so much, Ryan. I think we also have a Q&A session at the end, and let's go over some of the questions that came in. We saw just now in action what it means to have a system tackle an engineering case. And it's also very important to kind of plan the future along with it. Um, as organizations, we need to see, okay, what is the potential of this technology? And also maybe prepare for what kind of foundational blocks we need to go for these to be really successful and drastically impact business. And that's why I'm really happy to have Florian joining with us here today, who has worked with multiple customers all around the world on such bringing these concepts to life and into production. And he's here to share more on how to prepare an organization for implementing AI agents at scale. Florian, over to you.
Yes, thank you very much. Um, I will share the screen first. So can you see the presentation already?
Yes.
Yes, perfect. Yeah, thank you very much, Ram and Ryan. A great presentation. Text to spaceship sounds amazing. A very nice vision. I'm excited to see how this goes and how this project will develop too. And yeah, now I'm super excited to guide you through our insights at ARRK of the real-time multi-agent system implementations we did so far. And also what has to be prepared in your organizations for agentic AI implementation. But first, I will start with a few challenges, I would say, we are currently facing in Germany or in Europe. Germany was always an engineering country and a very innovative country, but there are a lot of competitors. For example, China. So 40% of all electric vehicle patents in the second quarter of 24 came from China. So you see, not only Germany is innovative, also other countries. And in addition, the productivity is low. So if you compare the cars per employee per year, which are produced from Toyota, compared to Volkswagen, Toyota produces more than twice as much cars per person. So yeah, maybe we have to get also faster to stay competitive. And therefore, or in addition, the modern cars are getting more complex. So a modern car has more than 100 million lines of code. That's even more than a commercial aircraft. And therefore, yeah, it's getting complex and even more expensive. So costs are already very high, but they will even double until 2030 if we don't change the existing vehicle concepts or development. So we need to get faster, simpler, and more cost efficient. The traditional engineering reaches the limits, so we need a fundamental change the way we operate, and the incremental improvements do not longer solve the issues we have. And this is why agentic AI becomes essential. And agentic AI helps us to get, as you can see on the slide, to get faster, simpler, and more efficient. And multi-agent systems are already implemented in a lot of different projects and use cases. And I will now share some insights, some best practices, some learnings we faced in our projects where we implemented multi-agent systems. Yeah, let's start. First, build automation foundation first. So I put on the slides like 5 key messages we learned, and I will tell you a little bit, a few stories from the projects, I would say. So build automation foundation first. Agentic AI or multi-agent systems sounds great. Management loves to hear multi-agent systems, but mostly at every, I would say at every customer projects, the clients had a aha moment where they realized that we don't only need AI, we also need sustainable and robust automation. And actually, this is most of the work, or not most of the work, but a lot of work. Synera provided a very nice multi-agent system framework, and it's pretty easy to set this up or to add an agent or to change the structure of the multi-agent system. But there is a lot to do for automation first. So the tools Ram mentioned have to be prepared. So if you have for example, a high voltage battery CAD model, agent can parameterize this model. And then if you tell him the car gets shorter for 10 centimeters, please also shorten the high voltage battery. There has to be a parameterized CAD model, which the agent can parameterize and then interpret the results. So yeah, you can see you need also automation and also parameterized models. You need, of course, as always for AI, consist and continuous data, and yeah, then AI really works. Next, don't automate broken processes. We really learned that you should double check your existing processes. Don't paint over rotten walls, said someone in the customer project. One story is that we had a very nice use case. We implemented a huge workflow, and then finally the testing phase came, and it wasn't very good. The results were different, and we didn't knew what was the problem. And we figured out the engineer who guided us through the user journey wasn't the engineer who provided us the results. So every engineer did the process slightly different, and therefore the testing did not fail, but wasn't as good as expected. And what we did was we consolidated the process and made one, I would say, optimized process, and every engineer brought the best parts of his process to the overall process, and then in the end everything worked, and the testing was also successful. And you see, you need rules, you need also good processes. For example, it's good to work with aircraft companies in multi-agent systems because they have rules for everything because of safety reasons. Please double check the process because AI can accelerate the workflows, but it won't fix the broken or efficient ones. Next one, structure your multi-agent systems. You don't have to, try hard to get a very big workflow. Things are getting very complex. Also, for example, the prompts for agents, especially the supervisor agents, get a lot of information about the background, the goal of this task, about the other agents. And then you have to, work very structured, maybe create a Synera workflow where you implement different parts of the prompting and then merge them together. So you have one, overall prompt because, your the prompts are getting longer and then mistakes can happen. Prompting is in general a bigger part than I expected at the beginning. Funny side story. We did not get an agent exactly to do what we wanted. And then, we tried to prompt with exclamation marks and also capital letters. The tone got a little bit more strict and aggressive. And then everything worked and the agents did what we wanted. So, be strict, but not too strict. There are also some filters. If you are too aggressive, then there will be an error as well. So in the end, to get back, structure your multi-agent systems, clear prompts, modular workflows, structured data interfaces, because things are easier to debug then. Keep it simple. We worked in a lot of different projects. When we started, there was no best practice and no, you do it like this or that. So we tried a lot. We gave agents more workflows, simple ones, complex ones, and tried things. And in the end, we learned, break it down to an easy level. We have one rule. If there is a simple rule to implement in a rule-based Synera workflow, for example, like an if case, if that happens, do that. If something else happens, do this. Then please implement it and don't tell the agent to also act like this. If this happens, just implement it, and then that's easier and also easier to debug. One AI expert said a multi-agent system is like a child. You train it to do certain things, and also for a child, you have to break down the thing you want to teach him to an easy level, and that's also a good advice for agents. Clear instructions, maybe also limit the scope, implement a transparent logic, and that also will help for maintainability and adoption. And then last but not least, keep humans in the innovation loop. Humans provide context, judgment, oversight. AI can do this partly, but still not as humans. And AI really helps to be innovative. So you can work and your work is valuable, and the annoying parts is done by AI. And you have a coworker, an easy coworker who always does the annoying work. And for example, in a RFQ process, everything is automated, and you don't have to write pages and pages for this RFQ document. You can just give this task to an agent. I guess the RFQ example was also mentioned by Ryan. And then you can so you can do 5 in the time you did maybe just one RFQ document, but more important, you can also focus to have an innovative RFQ document and not just a lot of text. You have the ideas then. So in the end, organizations must change to use the capacity and expertise for the given time we have. So don't be afraid to start with agentic AI. And now I'm already at the end. The only way to fail with agentic AI is if you fail to start. Start today and not tomorrow. I really can recommend this. Thank you. Then I will stop my sharing.
Florian, thank you so much. I think it was really filled with a lot of hard challenges that you came up, but you tried to paint it in a funny picture. But thanks so much for sharing all those insights. A lot of it, I think, comes from actual implementation. So a question that I have is, how do you encourage companies to prepare? I think there are companies that are in different stages. So maybe some organizations have already a lot of these things done. Some organizations typically have been a bit behind. And how do you advise? How do you measure how fast they need to go?
Yeah, so basically, it's not too late. So this topic is quite new. Yeah, we worked on this. So there is no multi-agent system expert with 10 years of experience. So we all started, I don't know, 2 years ago maybe. So yeah, start now, and then I would also recommend to yeah start small with a, but also with a scalable use case. But you have to build trust first. So start with an easy use case where you yeah get results. You can validate the results. You can also then challenge the agents with questions, and then the trust rises, I would say, and then you can scale. And of course, you always have to think about your current processes, as I already said, and your automation has to be done also. So please check your process, then do the automation, and then set up the multi-agent system. As I also mentioned, data is always important. So continuous data, consistent data, and then yeah, start, scale, and I would always recommend to validate the results. Check. So the good thing is in the Synera multi-agent system that you can really read everything what the agents do, what they think, how they communicate, how they are making their decisions, and therefore you can go through it and you can yeah see why they did what they did, and then yeah you see that they act like humans, and maybe they decided different but they have a good reason for that, and then you know, okay, I have to be more specific in my promptings, and then yeah, then the trust gets higher, I would say.
Yeah, I think you touched upon like the entire spectrum of things to happen. But that is, I think, is very good to know that it's not just building one tool and give it to an agent, but there's a lot of these ripple effects that happen. I want to have a look into the time and maybe summarize what we saw now and then get it to a Q&A round, because I see a lot of questions popping up.
Yes.
But again, thanks so much, Florian, and also thanks to you, Ryan, for presenting what's possible today. And that already leads me to kind of conclude that engineering is about to change. I think organizations are preparing to kind of reimagine how the structures could look like, or organizational chart. So typically we had engineers unhelped, but now with AI, I feel they are going to be more supported, more assisted, and have uh, uh, more capabilities to be faster. And as a summary, what I think we can all take away is identify business critical engineering processes where it's going to definitely give um, a bigger impact. And that already sets the tone that for agentic AI to be really game changing, we need to identify or be aware what are those critical engineering processes. Um, as we saw also in the demo from Ryan, I think designing a suitable multi-agent system. Also, Florian touched upon this. It's really in the design of these agents. How do we want to separate those individual agents? What kind of tools do we want to give them? What do we let the supervisor see and manage? So I think there's a lot of craft that is being created around designing multi-agent system that's also improving day by day. And I think the last but not least important point is the balancing that automation can also happen by creating tool workflows, and we try to use that as a mechanism to make the whole process faster with agents so that it's not getting too complex. I think that was a very good outlook into what's already possible today. I want to plug in two more things where we will keep talking about agents. Uh, as the year starts, we want to already show what we are doing here at Synera. more reflection on what we learned with working on agents in 2025, but also 2026 is more crossing this chasm of agentic AI. So we will be showing a lot of trends from last year, what's coming next year. So if you're interested, I would love to meet you all also in the beginning of the year. And if you're more interested in what those tools can do, we also have a webinar that's coming out with our partner Rufos Physics. And here we show how to model those real world physics into low code workflows, which you can then maybe give them to agents. So these are two good resources that are coming up and maybe a good place to keep meeting you all. With that, I think we can go into a short Q&A session. I already see a lot of questions coming, so let me try to moderate them. Over to you, Florian and Ryan. So I think a couple of questions that I will try to categorize them is, I think a lot of people asked about quality in terms of data and in terms of agent. How are you thinking about this? Data quality, agent quality, how are you measuring things? Maybe let's start with Ryan.
Sure. So I think you need to come up with evaluations that, sets of inputs. When at the end of the day, it's inputs and outputs. So really think in terms of inputs and outputs. So, come up with a set of evaluation inputs and what you expect the outputs to be, and iterate on that. And like Florian said, start small and simple. But then as your agents and your workflows get more sophisticated, you can look at more edge cases, or deal with more complicated requests. So that's one thing. And another thing, and I saw this in the chat, there's so many great questions in the chat, is, you can have review agents, right? So you can have an agent that is a critic, and maybe has access to some of your quality documents that can make sure that it's compliant.
Makes sense. I think those are really practical tips to have in mind or in written, have some test cases. Florian, how do you see these things in production? What kind of quality metrics do you see?
Yeah, so the issue is that most of the time one person sets up the multi-agent systems and gets all the automation Synera workflows, and then he or she doesn't really know the details of these workflows. And then it's harder for him to evaluate if the agent gives the right answer or not. And what we did is we implemented like guiding questions. So that's how an expert from us calls it. Every workflows comes with a few questions, and of course you don't want to train an agent to just answer 3 questions right, and everything else does not work. But for the beginning, for the start, it's good to set up this multi-agent system, to ask these guidance questions from time to time, and then you have to sit together and really challenge the system with complicated questions, and then evaluate together with all the experts of the different departments, if it makes sense.
Got it. I think it's more and kind of adopting to this new way of measuring automations and putting them into practice. That makes sense. I also see in the Q&A certain questions related to Synera, asking Dassault Systems, N8, and HubSpot. So maybe just to touch upon them so they get answered. We also have connectors to Dassault Systems, a lot of capabilities around that. So I definitely encourage you to check out our marketplace where you see a lot of these connectors. N8 is also an agentic automation platform with a specific focus on IT document operations. We have A2A and a lot of capabilities for engineering. And HubSpot, I guess, is more a lead generation tool. So I would say Synera is very much the agentic AI platform for engineering. That's how we try to focus. I see a couple of very interesting questions comparing what you showed, Ryan, and also what you showed, Florian. So Ameya asked, I heard 2 different stories. The NASA researcher which in case is Ryan, gave a presentation that pointed towards an MCP-like interaction. And in the presentation by ARRK, there seems to be a strong need for deeper homework before applying agents. Which one is true? Since I also worked a lot with Ryan and Florian, I think MCP is a way how to connect these tools, but creating those tools is still important. But let me give it to you, Ryan, first. What does your future look like with these different protocols and tool interactions?
Sure. So, all your workflows and all your data aren't necessarily going to be in one agentic system, right? So if you have, for instance, we have an MCP server around our NASA specs and standards. So if you need to go out and understand what relevant specs and standards are, you would go to that MCP server. So MCP server is just a connector to other things outside of one agentic orchestration platform. I think Florian and I were sort of telling the same story from different perspectives. I was giving a higher level view of the vision, and Florian really gave a lot of great information on the details and the challenges you have to overcome. But I completely resonate with everything he said.
Yeah, I also can align with this. So I don't see it as different stories because I just wanted to create awareness that it's not only putting a multi-agent system above a process. And we also implemented multi-agent systems with Python. And if you do that, then this is the most time-consuming part. The good thing is that in Synera things are easier and it's pretty fast and pretty adaptive. And then, of course, you have to create the tools for the agent. So, what is an agent? An agent has a tool, and if you don't have a tool for an agent, then it's just a LLM with background information. And these tools have to be parameterized, for example. So, worst case, you give an agent a hard-coded CRD model. How should the agent work with this model? So of course you have to do a little bit of homework, but I also align with MCP and A2A protocols. So this is, I would say, combined, but still, of course, it's not only put the multi-agent system on top and everything works fine.
Yeah, I think I would also agree to it. It's definitely coming from two different angles to the same conclusion. I see Kent asked a question that is in a similar direction. How do you address IP protection and compliance concerns for sensitive engineering data? I think that's where the Synera workflows as tools help a lot because Synera is an on-premise platform. That means it always runs on your infrastructure, your LLMs, your connectors, and so on. And that is already an elegant way to put in your IP and it stays within your infrastructure. Florian, maybe from you, I think this would have also been a question you would have been asked countless times. Where is my data going? How do you see questions around IP and how do you see it with Synera?
Yeah, so in most of the projects we work on um, on the systems of the customer, of the clients. So there is no data in the cloud or anything. So there is no problem at all. Of course, this is also possible. For example, we have now Synera Run hosted at AWS. And of course, there are a lot of layers, security layers. And yeah, so when these questions appear, then I always ask my security specialist because I'm not too deep into these topics. But we had these questions a lot, and I can assure you that everything is fine. And if you need more insights, I will call my colleague and he will tell you then how safe and why it's safe.
Yeah, Ryan, please.
So, I'm always someone with my eyes on the horizon. And I think it really gets interesting when you talk about having these, your system made accessible from outside AI agents. So the example I gave where you have a satellite battery agent at another company that, we might hit to get a battery design. And, you have to think about a lot with that, right? What information do you have to give them? How do you keep them from reverse engineering by hitting your agent over and over again? And then how do you when you're connecting to something external, that's a whole different ballgame. When you're a lot of these like company chatbots are internal first, because having an external facing AI system has a whole other level of rigor that you need. So I think that's where things are going to get really interesting, but also where it's going to be really powerful.
That makes sense. I think having this kind of a more broader perspective of what's coming in the whole technology world really helps. I think we will try to take up all the questions and reach out to you over email or with a follow-up summary for sure. But there is one last interesting question that I want to hear answer from you, Ryan and Florian. So what's your favorite LLM today?
Ryan, you go first.
It depends. So my sort of like daily life driver is ChatGPT 5.1. But I find that Claude has some different qualities and is follows directions better. Is a little easier to keep on the rails.
Mhm.
And then Gemini, like the Nano Banana Pro stuff is nuts. Like you just feed it like a bunch of information or like something you want to communicate, and it makes infographics that are just give it a try with making infographics. But you just have to keep pace because this changes like literally every day.
That's true.
Yeah,
Florian?
for me, yeah, it's boring, but it's Claude, definitely. So I really like all the different LLMs to create your own songs and everything. But since I come from the software development side, I really like Claude because I got the best results there, and this was the first time I really got high value from AI, from large language models. And yeah, there Claude is, I would say, the best and better than ChatGPT and so on.
Awesome. Yeah, I pay for all the pro packages, so everything is my favorite. So I can't let go of anything. But Ryan, Florian, thanks so much for joining us today. Thanks for sharing a lot of insights, a lot of also wisdom to people who will get started on this journey. And for everybody who joined us, thank you so much. We will try to reach out to you with most of the questions answered. A recording will be coming up. And if you want to get what's coming in 2026, feel free to already check out and register for our next webinars. Thank you all once again for joining. Have a great rest of the day and see you in the next one.